Have you ever wondered how machines can predict outcomes so well? One powerful tool for this is a neural network. In this video, we will break down with simple, relatable example, predicting a student's exam score. Let's say we have a dataset of students. For each student, we know how many hours they studied, the quality of their previous grades, the number of practice problems they solved, and we also know their final exam score. Our goal is to predict a student's exam score based on these inputs. To start, we could feed a straight line to relate the hours studied to the exam score. This would be a simple linear regression. But we know real-world relationships aren't always straight lines. What if we made it more flexible? Instead of a line, we could create a function that captures the relationship between the inputs and outputs, like a curve that adjusts better to our data. This function can be implemented as a single neuron in a neural network. The input here is hours studied, which we call X. The output is predicted exam score, which we will call Y. The neuron processes X with a simple mathematical function like a linear equation and ensures the output doesn't go beyond 0 with something called a ReLU function, which stands for rectified linear unit. Think of it as output equals to max of 0 plus Wx plus b, where W is weight and b is a bias. Don't worry about the weight and bias thing, we will explain more about it in the upcoming videos. Now, let's make it more interesting. Instead of just hours studied, we will add more features. Hours studied, quality of previous grades, number of practice problems solved. Each feature influences the student's exam score, but in different ways. For example, practice problems might help with understanding concepts. Quality of grades might reflect a strong academic foundation. In a neural network, we model these relationships with multiple neurons. Imagine a layer of neurons where one neuron learns how hours studied contributes to the score, another learns how practice problems contribute, a third focuses on previous grades. These neurons pass their output to the next layer, combining these insights to predict the final exam score. Each neuron in the hidden layer receives all the input features and together they form what we call a densely connected layer. When we train the neural network, we give it examples of X, the input features, we provide the corresponding Y, the actual exam scores. These networks adjust its internal weights and biases to minimize the error between its prediction and the true scores. Over time, the neural network learns to predict exam scores based on the inputs. So that's a neural network. It's like stacking Lego blocks. Each neuron or layer builds on the other to capture complex relationships in data. With enough training examples, neural networks can become incredibly accurate, helping us predict outcomes like exam scores, housing prices, or even more complex problems. If you like this video, don't forget to press the like button and also subscribe for more amazing videos like this. Bye.